Hi everybody, I'm Chris Bergen, Business Development Manager for Amazon Connect. I'm joined today by Robert Killery, Lead Product Manager for Amazon Connect, and Joe Sullivan, Principal Engineer for Amazon Connect. Today we're going to talk about IoT and Amazon Connect. First, I'd like to have you look at this and think for a second. The problems we're going to focus on today is around improving customer service. Take a typical customer service experience. Every one of us here has called into a contact center service before to try and get service on something that's broken. How many people, I guess I should start before I jump into this, how many people are already familiar with Amazon Connect? Fantastic. How many people are like 200 level IoT? Okay, that helps a lot. Thank you very much. So in a typical customer service experience, let's imagine a water heater. And your water heater is broke. You're at work, you've come home at the end of the day, there's water in your basement, super frustrating problem, you have to find a water heater company, call them, and then you get an experience where you hit the call center. Oftentimes, the call center offers you a number of choices. You choose support, and it requests more information. What type of support? What's your device? Eventually, you get to an agent. When you get to that agent, what's your experience typically like now that you've given all that information? Who am I speaking with? What kind of problem are you having? And what is the device, your serial number for your device? That's super frustrating. We've released Amazon Connect on March 28th, which 90% of the room already knows about, which is great, specifically to solve these types of problems, to make that scenario better. But today we're going to talk about not just Amazon Connect, but Amazon Connect layered with IoT and how those two services together can improve this experience. Amazon Connect is, you know, that the pieces of the solution that help make this possible within Amazon Connect are the contact flows. The contact flows are where we can create the personal experience, and we can embed both Lambda and Lex as a way to integrate with back-end systems, and Lex to create a natural experience. Another key contributor to improving this experience is being able to have an open system. In this diagram, how many people have seen this diagram before? Okay, couple. So I'll walk through it. In the middle, you've got Amazon Connect. And on the right, we fund Amazon Connect, the application. But this is showing how you can get you can integrate with the solution outside the application. First, on the right, you'll see that call recordings, metrics, and agent data can all be sent outside the system to AWS services and other services. Top right, all your call recordings are stored in S3. You can choose a bucket, or Amazon Connect will create one for you when you launch your application. In the bottom right, you can use Kinesis to stream contact center data to your data warehouse. It could be an AWS service like Redshift, or it could be a third-party data warehouse of your choice. And oftentimes, contact centers have a tool like workforce management to help effectively schedule agents and make sure that you have the right amount of staff to handle the call volumes or the call arrival patterns that occur throughout a day. So we can stream data to that workforce management system so you can make more informed decisions and better staff your contact center. On the lower left, there's the integration at the agent level. The agent in a contact center has with Amazon Connect, they have a soft phone capability. We call that our contact control panel. And we offer the telephony functionality that an agent needs in that contact control panel, such as answer a call, make themselves available, change their state so that they can go on break. But we also have the ability, or those capabilities, oftentimes you want that in the same application that the agent's using to identify the customer. Going back to our use case, the agent now has to ask the information, or we've all experienced they ask for this information, even though you gave it in the automated system, you ask for it, they're looking you up in a CRM or some application so that they can get more information about you. So we believe that many customers will want to put that contact control panel in the application that the agents are using where the customer information is stored. So we have an API available for that. You can embed the contact control panel. We also have out-of-the-box integrations for popular applications like CRM, such as Salesforce, Zendesk, Zoho. But you can easily create an integration with your custom applications. We also leverage Lambda. I talked a little bit about creating a personalized experience, but in the top left, what really enables that is Lambda. And we embed Lambda in a contact flow. And for those that don't know that term contact flow, think of it like an IVR application, except it can do more. It allows you to create there's a canvas, which Joe will be showing a little bit later in a demonstration. But there's a canvas where you can drag actions onto the canvas and control the customer experience. One of those actions that you can drag onto the canvas is to trigger a Lambda function. That Lambda function can look into an application like CRM or business intelligence or a data warehouse, and it can get information about that caller, and then not only can you route the caller specifically based on that information, but you can also create a customized experience for them. This is the key to leveraging IoT as well, so it's important we understand this fundamentally. Oh, sorry, I went backwards. Okay, so now we're thinking about that problem and how can we leverage IoT in this experience? How can we combine IoT and Connect to make this experience better? First, you've got connected devices out in the world, okay? And if we can make those devices connected, they can send information back to the cloud, but connected is only one piece of the puzzle. The second piece of the puzzle is coordinated. And that's what we're really excited about at AWS is the idea of sending information to the cloud from the device, such as how it's performing, and then looking at that data with your customer data to understand where that device is, what was that person's last interaction with that device, have they called before, are we seeing signs that this device is failing just based on the amount of times they've called in and the information that it's sending? So we get that information and we coordinate it, and now we can make decisions and execute decisions within Amazon Connect. So IoT, this is a visual representation of the services that AWS offers with IoT. The key to this slide is that you could see that the data from, in our example, the water heater, is being sent, if it was IoT enabled, that data could be sent up into the cloud. It could be processed through a rules engine, and then it can trigger using other AWS services. So it could send data through Kinesis, it could leverage Lambda to trigger Amazon Connect, and that's what we're going to focus on today. The impact of this, if somebody could put this together, is that it could deliver an improvement in both operational efficiency and top-line revenue. And I'll explain that in a minute. It also can deliver better customer experience because instead of having to think about a reactive customer experience where your water heater broke and now you're frustrated and now it's an urgent issue for you and you have to call, what can we do to make that experience proactive? Maybe even thinking through that problem could result in a new business model. What if it was water heater as a service? Okay, what if we could rent the water heater? So let's look at the scenario, that same scenario, if the water heater were IoT enabled and we all created a new business where we were paying monthly for a service or paying incrementally for a service for our water heater to ensure that that thing always runs. The water heater now, we don't have to wait till it fails. We know it's underperforming. Many times in a water heater, there's two heating elements, one on the top, one on the bottom. You might not know when your top heating element goes out. To you take a 3-minute shower, the water was hot, everything is fine. But one heating element is out. That information, the temperature can be monitored in the tank, information could be sent to the cloud. We notice a fluctuation in that temperature, trigger an event, and contact the customer. Now, when we contact that customer, what's their experience going to be? Depends on what they'd like. They might prefer, based on if it's potentially a heating element is out, that might not be as critical as water leaking on the basement floor. So we might send a text notification and say, hey, there's something we're recognizing with your water heater. We'd like to get out. You could have a virtual agent. You could offer them the ability to schedule an appointment and have a virtual agent do that. Is everybody familiar with the concept of a virtual agent? Okay, Amazon Lex is the service that we use to create those virtual agent or chatbot scenarios enabled by voice. And then, of course, you could, if it's an urgent matter, they might want to receive a call handled by a live agent, somebody that can help them right away. So now the experience is this. This customer gets this experience as opposed to having to make a call in. So let's talk about the pieces of the puzzle that we're using here. First, to enable this, we have the water heater. It's sending data to the AWS cloud and using IoT. And in the IoT, the rules engine is processing that information and triggering a Lambda function. Lambda is looking into the customer data, into CRM to understand more about that customer, where they are, what their preference for contact is. Do they want to be called? Do we have their cell phone number? Can we text them? And then we're using Amazon Connect and Pinpoint as the communication method out to the customer. At this point, we're going to walk you the rest of the way through demos, an architectural overview, and then we're going to go into each service and show you how we built these demos. I'm going to hand it over to Joe.
Thanks, Chris. So in the first scenario, thanks, Chris. This is the urgent scenario of water leaking on your floor. So you come home, there's water all over the place. This is what we think of as an urgent outreach. Something went wrong, you need immediate attention. And so we're going to use Amazon Connect for that. So to simulate the water heater scenario, we're going to use a AWS IoT button. And so if I click the button, network. Sorry, our Wi-Fi is not quite working. Okay, so if I click the button, my phone rings. We're using Amazon Connect and the new outbound API to call out to the customer.
Hi, Nikki Wolf. This is Acme Plumbing. A water leak has been detected in your home. Would you like us to send a plumber to your home right away?
Yeah.
We are sending a plumber to your home now. We will give him or her this number to contact you when he reached your home.
So that's a fairly simplistic scenario. We used the outbound API. We called out to the customer. What was interesting there is it was personalized. We knew who you were. We recognized you, we greeted you, and we gave you the option of speaking to an agent or dispatching a technician right away to fix the problem. So that was put together with Amazon Poly for text-to-speech in the contact flow, as well as Amazon Lex for handling that natural language voice bot experience. And so the second example we're going to show is the mobile notification via Amazon Pinpoint. So very, very similar scenario. Do you have the button, Robert? Yeah. So in this world, you'll see we send an SMS to your phone. We notify you that we've detected an issue with your water heater. We give you the option to schedule an appointment at your convenience. Using Amazon Pinpoint, you could build more of a conversational interface if you wanted to reply via SMS. You could also use push notifications on a mobile device if you want to integrate it more with your mobile application. So you can see if I click on this link, I'm given the option to schedule a callback. I could pick a time and a date. I could click call me. It already knows who I am. It knows all of the data associated with my account. So at the point of picking up the phone, once more,
Hi, Nikki Wolf. This is the scheduled call you requested about your water heater. We are connecting you with a technician who can help you troubleshoot the issue. Thank you for calling. Your call is...
So similar experience. We know who you are. You're able to request a callback. You're able to specify when you'd like us to call you at a convenient time, and we're able to connect you with a technician to figure out how to resolve the issue. So now we're going to walk through how we actually built this. So starting in the AWS console, we have AWS IoT. And so in this example, we don't have a water heater. We have an IoT button. And so we've registered a couple of IoT buttons in our account. And each button has associated with it a device serial number, so a unique identifier associated with the device. In the IoT service, you can associate arbitrary metadata with these devices. So if you want to tack on data about these devices, what they represent, who they represent, you can do that in IoT. You're also able to write rules in the IoT system to configure when actions get invoked. And so we have a fairly simple rule in our world where we essentially just invoke a Lambda function. So we have a trigger. It says that anytime, sorry, let me pull up my Lambda function. Anytime the IoT button is pressed, we have this trigger that says anytime one of my buttons is pressed, then invoke this Lambda function. And we'll dive into this Lambda function and what it's actually doing. So I press my button. I get a payload here that tells me what serial number was pressed and what type of click it was. And so we're using this in our example to discern between an urgent scenario and a non-urgent scenario, so the immediate callback versus the push notification. And the first thing we do is we load data from DynamoDB. And so we're storing all of our customer data within Amazon DynamoDB, which is a non-relational database product that we have. So you're able to store data associated with items. You're able to retrieve this data, highly scalable, very fast. And so we load this data out of our table based on the device serial number that you saw before in the IoT service. And once we get the item back, we decide what to do with it. So if this is an urgent event, then we use the Amazon Connect outbound API to place a callback immediately. And so this is an API that we released a week or two back. It's in preview mode right now, so you could request access to it. And so the Amazon Connect outbound API allows you to trigger a call out to a phone number and to run a contact flow once the user picks up the phone. So you could think of it as an agent playing an outbound call, placing an outbound call, but there's no agent in the loop yet. So anything that you can do in a contact flow in terms of invoking LexBots, building custom and personalized experiences with Poly, you can continue to do in these contact flows once your customer picks up. So the full power of Amazon Connect for outbound calls. And so we call the phone number associated with this registration. So this is data that we got back from DynamoDB. We tell Amazon Connect what contact flow to run. So this is really, like Chris said, defining the full customer experience and the full customer journey and how you want to handle that customer. And you tell what Amazon Connect instance you should do this in the context of. So you could think of an instance as a virtual contact center. Many companies will have an instance per department or per line of business. They might have instances dedicated to development or production workloads. And so you're also able to associate attributes with the contact in Amazon Connect. And so these are key value pairs. This is any data that you want to pass into Amazon Connect. And it can be leveraged within Amazon Connect in the contact flow. And it could also be leveraged by other services that Amazon Connect integrates with. So if you call a Lambda function, if you invoke a LexBot, you could pass all of this data down so that you know what to do with this contact based on the data. All of these attributes will also be persisted on the contact trace record, which is our historical record of the contact and what happened. So you can get that out to a data warehouse. You could run custom analytics on top of it. And it'll further be provided to the agent call control panel. So when an agent gets one of these calls, you're able to display this data. You're able to suggest actions for the agent and really cut to the chase so that they don't have to ask over and over again for information you already know. And so you could see that if it was a urgent message, we'll go ahead and, sorry.
Now, just make sure I'm on. Not not every application requires code. You don't have to use Lambda to design your entire contact center. We're showing Lambda functionality now, but we're also going to show you how this fits into the contact flow in Amazon Connect.
Yep. I could try.
It's a web browser, right? Control P or Control Plus.
Yep. Is that better? Okay. So you can see if it's an urgent event. So if it was, if it's an event that we deemed as urgent, we call this outbound voice contact API on Amazon Connect. And if it's a non-urgent event, we build up an SMS message. So this was the message you saw before. We say we've detected an issue with your water heater. We pass you a link to a website, and we pass along in that link the serial number associated with your device so we could later look you up and give you a personalized experience when you come back in. And so this is using the Amazon Pinpoint API to send this message to the phone number associated with the device. So very similar to the Kinect integration, all standard AWS service APIs. And so past this point, if we look at what this data in Dynamo actually looks like, this is a simple example for you. In the real world, you'd probably be interfacing with an existing customer data system you have, maybe a CRM application, some other database that exists at your company. You're able to pull data from within Lambda or within Amazon Connect and make decisions based on it. So this is showing the set of data that we're passing in to Amazon Connect. So first name, last name as attributes. And so the experience, like we've talked about a number of times, contact flows define the full customer experience and journey. And so if we look at this urgent issue flow, you can see the behavior of it. It's a fairly simple flow. You can build these really as complicated as you want. You can
make it a little bigger, Joe.
Oh, sorry about that.
It's good.
Good. Okay. So you can make contact flows as complicated as your business needs really dictate. You can see here the first thing we do is we invoke an Amazon Alexa bot. And so we're using the data that was passed in from our Lambda function. So those attributes that we saw before from Dynamo. You'll see that we referenced the first name attribute and the last name attribute. So we're greeting the caller. And we're at that point invoking an Amazon Alexa bot. We're invoking this bot called Yes No. And so this is a very simple bot. You could use Amazon Alexa to build full natural language experiences, full conversational voice bots. In this example, we're really just reacting to yes or no to keep things simple. And so you'll see we spell out the bot name here, and we'll look at that in a second in our account. And any parameters you want to pass to the bot, you can do so here as well. So if you want to pass an attribute that was passed in, such as the first name or the device serial number to look up data on the Alexa side, you could do that as well.
And just, Joe, just to go back while you're on the contact flow, just the general concept of the contact flow is you drag these boxes onto the canvas, and if you click out of that for a second, Joe,
absolutely,
and show the choices on the left. These choices on the left are all the options you have to be able to control the customer experience and drag boxes onto the canvas. So we kind of jumped right to Lambda because that's where we're getting a bunch of information from the IoT device to trigger the event. But you can do things like drag a prompt onto the canvas. You can collect an attribute. Maybe you talk through some of those, Joe.
Yep.
Yeah.
Yep. Absolutely. So really, any of the experience that the customer is going to have, you're in full control over. So playing audio, changing the voice that they experience via Amazon Poly, changing the language to play audio back in, changing whether calls are recorded or not, as well as being able to really react to data within the contact center environment itself. So being able to know if queues are at capacity or there aren't enough agents to handle this right now, or even that you're simply out of hours. You have full control over that. You can shift volume as needed based on what's happening in real time.
And I think the key here is that a business user can use the boxes on the left to control a very simple customer experience. And if you can have a developer with Lambda get some information, you can create a very customized, very personalized experience, as Joe's showing you.
Yeah, and it also gives you the ability to pre-stage things in here so that you can respond to other events. You know, how many times have we had a scenario where weather or natural disaster affects your operations? You can build into these right here so that that can be accounted for and operations can address it without having to reach out to technology or to the developers.
Yep. All right, so coming back to this example, we invoke a LexBot, we collect some data. If the customer says, yes, please send a technician, then we simply tell them that we're going to send a plumber to your home and expect to hear from us shortly. You would likely invoke a Lambda function or similar at this point to actually request a resource like that or figure out what scheduling information you need. And so all of that is available within a contact flow. And otherwise, you could route to an agent. So if the customer says, no, I need to talk to someone, you have the ability to select a queue to route them to, transfer them down to that queue, and get them serviced that way. And so stepping over to Amazon Lex, that simple bot we saw before, to create a bot like this, you really just need to define your set of intents, right? So the set of data that this bot is going to end up with. And so this is a simple bot. The intent is either no or yes. And so when you create each of these intents, you associate sample utterances. And so,
quick question.
Yes.
How many people have been in Amazon Lex? Fantastic.
Excellent.
Great. And so these sample utterances don't need to match exactly. So you're really giving samples at this point, and you're trying to think of the different things that customers might say when they interact with one of these bots. And if they say something that doesn't exactly match, Amazon Lex is smart enough to really build up a model and fill in the blanks. If there are cases where utterances don't match at all, you're likewise able to go into Amazon Lex for your bot, look at what it's captured to date, what hasn't matched, and then go back and retrain your model to make sure that you're really accounting for everything that your customers are feeding you. Likewise, this bot isn't collecting any actual data. It's really just collecting an intent. Amazon Lex has the concept of slots, and so these are really pieces of data that you want the bot to collect. What's your name? What date will you be home for this appointment? Things like that. And so the bot will collect this information from the user, fill in the slots as it goes, and then all of that data will come back to Amazon Connect. You could access it within your contact flow. You can make routing decisions based on it, or you could just associate it with your contact trace record to further send that data through to your agent. Okay. And so that covered the urgent callback scenario. That was all that was involved there. And so in that world, you use the outbound API, you trigger a callback, you look up some data in Dynamo first, pass it all along. Amazon Lex is invoked, you interact with the customer a bit, and then you disconnect. And now we're going to go through the non-urgent use case. And so, I'm sorry. In the non-agent use case, we send an SMS, and you see that we pass this URL along. And all this URL is doing is it's collecting some data in terms of when to call and what phone number you'd like to be called back on. And at that point, it's invoking an API on Amazon API Gateway that we wrote. And that's a simple API that really is just passing straight through to a Lambda function. And so we're going to look at that Lambda function. So there's this place call Lambda function, and it's going to look very similar to the...
Make it bigger.
Yep. It's going to look very similar to the other one that we saw. And so in this place call example, a user on a website clicks a button on their phone. They say, give me a call back tomorrow at 7 a.m. All of that data comes in here in terms of what phone number to call, what time to call, what the device serial number is. So just like before, we're looking in our Dynamo table, and we're fetching the data associated with this device serial number. Once we have that data, we're able to build up this event here in terms of when this call is due, what phone number to place it to, what contact flow to execute when the call is placed, and all of the attributes associated with it. So again, things like first name, last name, whatever we had in our Dynamo table at that point.
Yeah, this is a perfect spot. A lot of times people are concerned about security and controlling the calls that are made with their systems. In the functionality here or in the CRM, you have the ability to build in whatever controls are appropriate for your business. So it may be that you don't want to present a phone number box to them, but only allow them to pick one that's on their account. So the compliance security aspects that you need to build in, protect both your customers and your business, this is one of the areas that you could place that in.
Yeah, and the other thing that customers find powerful with the outbound API is that since you're getting a request from a user, you're invoking an API, you do know who they are, you're able to authenticate them, you're able to have a much higher level of trust than if they call your phone number directly over the public telephone network. And so in this world, we bundle up all this data, and what we're doing is we're invoking a step function. So this is using AWS Step Function Service, which is a service for distributed application orchestration. So I know that's a mouthful. You could think of it as being able to model really almost like a contact flow, but the workflow associated with a piece of work, being able to stitch together service calls or tasks, being able to invoke Lambda functions and react to events. And so we're using step functions in this case in order to delay the call. So in order to wait until this expiry date that you picked, we're using this step function. And so we're starting this execution, and I'll show you what this looks like. If we go into the step function console, you'll see this scheduled callback state machine. And if we look at the details for it, it's very simplistic. So you define a step function state machine with JSON. There's an Amazon state language that really controls how these things react. And so this is a very simple state machine. It's starting off, it's going to this wait state. And so this is going to wait until that expiry that we passed in. And so this is slurping out of that input payload the expiry date and saying, wait until tomorrow at 7 a.m. or wait until next Thursday. And once that time has elapsed, it's going to go to this place call state. And so you'll see this place call state below that's saying, at the point of invoking me, trigger this Lambda function, so this place scheduled callback function. And what's going to be passed into that is all of the data associated with the state machine right now. So all of the data from the previous state, which in this case will be the data we originally passed in from Lambda. So the phone number to call, the DSN, the first name, the last name. The other nice thing about step functions is that it does give you full insight into what executions have happened. You're able to dive into a history, see what happened, see what went right, see what went wrong. You're able to also retry within these step functions. This is a very simple one that is really just invoking this Lambda function. So if we look at this place scheduled callback function, oops, we'll zoom in again. So this is really simple. So step functions is invoking this function. And the only thing we're doing is once again calling the Amazon Connect outbound voice contact API. And so we're passing along the set of attributes that came in from step functions. We're passing along the phone number to call. So again, this is data that came in from the step function workflow. And we're passing along the contact flow to invoke. And so in this case, what we passed along originally was this non-urgent contact flow. And if we look at the non-urgent flow, it's very simplistic. We're again personalizing it. We're slurping data out of these attributes that were passed along. So we're welcoming the user. We're informing them that this is the scheduled callback they requested about the water heater, and that we're going to connect them with a technician to help them troubleshoot. And so this is a very simple contact flow that's playing some audio, putting the customer in a queue, and then routing them to an appropriate agent.
Yeah, this is a great place where if you're looking for automation, maybe off-hours handling, a LexBot that's more advanced and able to schedule an appointment could be a perfect place here where it can actually let the customer interact with Lex, pick the date, pick the time, get it confirmed on the scheduling software for, in this case, the plumber, and then give the confirmation back to the customer. So depending on what level of human touch versus automation you're looking for with the business, these contact flows give you that opportunity. And it can be dynamic based on call volume coming in, who's available, et cetera.
Okay, so those are the two demo scenarios we outlined. You could build from there. So this is really just intended to get people thinking about what is possible. So these were fairly simplistic, both on the IoT side, on the Amazon Connect side. You could build much more complex scenarios based on what your business requirements are. And they really follow the same model. And so our goal is really to make these things simple to do, easy to do, and make for compelling customer experiences. So with that said, are there any questions right now?
There's a mic in the middle of the room. If you'd like to ask a question, we're happy to dig deep into any area you'd like to go. Doesn't look like there's any questions, so we'll probably wrap up. I'm going to put this back over here. There's another session on Amazon Connect this afternoon. It's our last one of reInvent. If you're interested in diving deep into I don't know what happened. changed, go to the end. Oh, there we
There
go.
you go.
Okay. If you're interested in learning more about Amazon Connect and Lex and how those two solutions work together to build a natural experience so that you can use the bot to create these experiences when you reach out to customers or even when they're reaching into you, you can attend that session. And also, please complete your evaluations so that we can do more Connect things next year, more presentations. Thank you very much for your time.
Thank you.